C, C++, C#. What exactly is their relationship? Upgraded versions? Inheritance? Or completely different languages? In reality, although their names look very similar, their natures are entirely different. The story goes back to the 1960s. At that time, programmers mainly wrote programs in assembly language. Assembly ran fast, but development efficiency was extremely low. Later, the University of Cambridge developed a language called BCPL. It was easier to write than assembly and more suitable for developing operating systems. Then Ken Thompson at Bell Labs felt BCPL was still too complicated, so he simplified it heavily and designed the B language. Yes, it really was just one letter, B. Later, Dennis Ritchie redesigned the B language, adding data types, introducing pointers, and improving memory access. Finally, in 1972, a brand new language was born. They defined it as the next step after B, that is, C. So C is not an abbreviation, nor does it have any special meaning. It was simply named in alphabetical order. No one imagined that this simple letter would influence the entire computer world for decades to come. Linux, Git, Redis, SQLite, and many embedded systems are still heavily written in C. Why is that? Because C's biggest characteristic is that it places almost no restrictions on programmers. You can directly manipulate memory and control every byte. Almost whatever you write, the CPU executes. It stays very close to the hardware, so it is fast and has low overhead. But at the same time, it requires the programmer to manage almost everything themselves. Memory allocation, resource release, array bounds, null pointers. Any small mistake can crash the entire program. As software grew more complex, the problems became more obvious. People began to think, is there a language that keeps C's performance but also helps programmers manage increasingly large code bases? Then C++ appeared. Many people, upon first seeing C++, think the plus sign means an upgraded version of C. If you have written C or C++, you must have seen this line of code. This symbol is the increment operator. The name C++ is actually a programmer joke. What it really means is C++, that is C plus 1. It takes one step forward from C, not to overthrow C. So what did that step actually add? Many textbooks will tell you C is procedural, C++ is object-oriented. That is not wrong, but it is not the real reason C++ was born. Software was becoming larger, hundreds of thousands, millions, or even tens of millions of lines of code. If you still developed entirely in the C way, maintenance costs would keep rising. C++ introduced many new abstraction capabilities. Classes, objects, templates, generics, RAI, the standard template library, all of these share one common goal: to let programmers organize more complex software. However, although C++ adds many high-level features, in the end it is still compiled into native machine code. So the CPU does not know about objects or templates. What it sees is only machine instructions. Thus, C++ does not give up performance. It only pushes complexity as much as possible to the compilation phase. That is also why many high-performance software still chooses C++. Chrome, Unreal Engine, LVM, and many game engines and databases. But the story does not end here. Later, another language with an even stranger name appeared, C#. Since C++ is +1, is C# plus one more dot? Of course not. The sharp symbol comes from the musical sharp psi, so its real name is not C# or C number. Then why did Microsoft give it a name starting with C? Because they wanted developers to feel familiar. But C# is already very far from C in terms of lineage. If we must say which language it resembles more, it is actually closer to Java. In the 1990s, Java introduced a very important concept: write once, run anywhere. The program is not directly turned into machine code. Instead, it is first compiled into an intermediate form, and at runtime, a virtual machine translates it into real machine instructions. Later, when Microsoft designed a C#, it adopted a similar approach. So a C# program is not handed directly to the CPU. It is first compiled into IL, intermediate language, then handed to the CL, the .NET runtime environment. Finally, a JIT compiler translates the parts that actually need to run into machine code on the fly. Therefore, the biggest difference between C# and C++ is not syntax, but how they run. Let us look at the same piece of code. In C++ and C#, the syntax is almost identical, but the process behind the scenes is completely different. If we compare the three to travel, C and C++ are like buying a direct ticket. You get off and you have arrived. C# is more like taking a plane, then a high-speed train, and finally a taxi to the hotel. The route is longer, but the whole journey handles many things for you: garbage collection, memory management, exception handling, and a rich standard library, so development efficiency is much higher. So what are they each suitable for? Which language should you learn? The answer, of course, is there is no best, only most suitable. C teaches you how to talk directly to the computer. If you want complete control over hardware, writing operating systems, device drivers, or embedded development, then C is still the most classic choice. C++ teaches you how to build complex software without sacrificing performance. If you aim to develop large-scale software, game engines, browsers, databases, and you pursue performance while needing better code organization, then C++ is more suitable. C#, on the other hand, shows you that many low-level details can be left to the runtime. If your goal is to rapidly develop enterprise software, desktop applications, web backends, or Unity games, then C# will make you much more productive. Understanding the relationships among them gives you not just knowledge of 3 languages, but insight into why modern software has evolved into what it is today.